A ship's anchor is vital for holding a vessel securely in place, preventing it from drifting due to wind or current. Anchors dig into the seabed, creating a strong point of resistance. The design of an anchor has evolved over millennia, yet the fundamental principles remain largely unchanged. The main components of a traditional anchor work in concert. The shank is the long central stem of the anchor, connecting it to the anchor chain or rope, known as the rode. The shank provides the necessary length for the anchor to orientate itself correctly on the seabed. Typically made of high-strength steel, the shank must withstand enormous forces. The point where the rode attaches is called the shackle ring. At the bottom of the shank is the crown, from which the arms or flukes extend. The flukes are the broad, shovel-like parts of the anchor that dig into the seabed. When a horizontal pull is applied to the shank, the flukes are forced downwards, burying themselves deep into sand, mud, or shingle. Some anchors have fixed flukes, while others are designed to pivot. Many traditional anchor designs also feature a stock, a bar set at right angles to the shank. The stock ensures the anchor lands on the seabed in the correct orientation. The initial lowering of the anchor must be controlled to prevent it from simply dropping in a heap. Setting an anchor begins with selecting a suitable anchoring position, considering water depth, seabed composition, and potential swinging room. The anchor is lowered under control using the ship's windlass. Once the anchor is on the seabed, a horizontal force is applied by allowing the ship to drift slowly astern, or using the ship's engines gently in reverse. As the vessel moves, the anchor rode begins to straighten, causing the flukes to pivot downwards and start to penetrate the seabed. The deeper the anchor buries itself, the greater the resistance and thus the stronger the hold. Mariners use various methods to confirm the anchor is properly set, such as observing landmarks ashore or using navigational instruments. If the ship continues to move astern beyond a certain point, the anchor may be dragging. Once the anchor is deemed to be holding firmly, additional rode may be paid out to increase the security of the hold. This careful process ensures the vessel remains stationary. The anchor rode, often a heavy chain, plays a significant role in the anchor's holding power. The weight of the chain helps keep the pull on the anchor shank horizontal. This leads to the concept of the catenary curve, where the chain sags downwards, forming a curve. This curve acts as a natural shock absorber, smoothing out jerking motions and protecting the anchor from sudden sharp tugs. The effectiveness of the catenary is influenced by the scope ratio, the length of anchor rode paid out relative to the water depth. A higher scope ratio results in a more pronounced catenary and a more horizontal pull on the anchor. A well-designed anchor, appropriate for the seabed, deployed with sufficient scope, will provide the greatest holding power. Despite careful procedures, anchors can sometimes drag, meaning they are not holding firmly and are being pulled across the seabed. Common reasons for dragging include an improper set, unsuitable anchor for the seabed, and insufficient scope. Preventing anchor dragging involves good seamanship and awareness. Ensuring the anchor is properly set, using an adequate scope, and regularly checking the ship's position are crucial. There are several common types of anchors, each with its own strengths. The plow anchor is a popular all-rounder, known for its ability to reset itself if it breaks out. The Danforth or fluke anchor offers high holding power in sand and mud, but can struggle on hard or grassy bottoms. The Bruce or claw anchor is good in various conditions and tends to set quickly. Choosing the right type for the expected conditions is key to safe anchoring. Weighing anchor requires a coordinated effort, typically using the ship's engines to motor towards the anchor's position. This maneuver takes the strain off the anchor rode and reduces the load on the windlass. The aim is to position the vessel directly above the anchor, changing the angle of pull to make it easier to break free from the seabed. Once the ship is vertically above the anchor, the windlass continues to heave, encouraging the flukes to break out of the seabed. If the anchor is deeply embedded or caught on an obstruction, considerable force may be required. Once free, the anchor and chain are hauled aboard, and the anchor is secured in its stowed position. Occasionally, challenges can arise during anchor retrieval, such as fouling on an underwater obstruction. In summary, correct anchoring techniques are fundamental to the safety and operational efficiency of any vessel. The humble anchor, when used correctly, provides security and peace of mind in the ever-changing maritime environment.